And it is a Wednesday.
Well, you should have never watched that movie. PreCal, dude. Freaking last night. And I watched that movie, bro. It's the best movie of my life.
All right. Okay, so last class, okay, let me remind you what we did. Okay, you remember that last class we learned how to find holes and vertical asymptotes. Do you remember that? Okay, so we're going to put computers away for right now, please. Okay, when we're done with notes, you'll have those back out, and that's totally fine. But for right now, let's put those away. So last time you found holes, vertical asymptotes, x and y-intercepts. Today we're going to add one more thing to that. So if you already understood last time's notes, today shouldn't be super hard. Okay, we are going to now find horizontal asymptotes. This is what x is doing at the ends of the graph. Okay? So there are three little acronyms that you're going to use to find horizontal asymptotes: BOBO, BOTN, and BEDC. Okay, BOBO stands for bigger on bottom. And if your equation is bigger on bottom, then your ends go to 0. So BOBO is bigger on bottom 0. All right, let me give you an example of that. Okay, remember, we're doing rational functions, which means you're having x's in a fraction. So I need the bigger x's to be on the bottom. So I'm going to do a 3x plus 5 and a 3x squared plus 10. Okay, out of the two x's, x squared is bigger and it's on the bottom. That's what makes it a BOBO. Now, this is what your graph might look like. Okay, the ends of the graph have to flatten out to 0. So it can do whatever it wants in the middle. But at the end of the graph, it's going to curve off to 0. And on the other end of the graph, it's going to curve off to 0. So if your equation is bigger on bottom, that's what's going to happen. Okay, the next one is BOTN. So BOBO's bigger on bottom. What do you guess the beginning of BOTN is? Very good guess. Bigger on top. Okay, if it's bigger on top, you have no horizontal asymptote. So take the equation that you wrote for your first example and just flip it upside down. Because now we want the bigger x to be on top. So I'm going to put the 3x squared plus 10 on top, a 3x plus 5 on bottom. Now, if you do not have a horizontal asymptote, all that means is that the ends of your graph aren't like curving off to a certain number. They're just either pointed up or down. So draw yourself a little graph. Whatever you want in the middle, doesn't matter. Okay, but then your graphs aren't going to flatten out at the ends. They're just going to go, like I said, up or down. So I'm going to make this side go down, and I'll make this side go up. Now, just like we talked about with even and odds, they could point the same way. They could point opposite ways. Okay, but the point is they're not flattening out towards anything specific. Okay? All right, last one is a BEDC. Okay, so the bottom could be bigger, the top could be bigger, or they could both be equal. If they're equal, to find what they go to, you're going to divide the coefficients. So let me show you what I mean by that. Let's give a little example here. Y equals, let's make it a 10x squared plus 3 over a 5x squared plus 8. So the first question I would ask you is, where's the bigger x? And then you would say, okay, well, the top is an x squared. The bottom's also an x squared, that makes it a tie, yeah? Then you would divide the coefficients in front. That'll tell you what those ends curve off to. So what is 10 divided by 5? Then your ends are going to curve off to 2. Okay, and then let's draw a little graph of that. So give me a little graph here, whatever you want in the middle, doesn't matter. Let's approximate where 2 would be. So I'm going to go 1, 2, draw my line in. And the ends of your graph are going to get really, really, really close to that line, but not actually get there. So they're going to curve off to 2 this way, and then curve off to 2 this way. So an asymptote means that your graph is getting really close to that flat line at the ends of the graph. Okay, it doesn't tell you what happens in the middle, just tells you what the ends are. Okay? All right, so let's just run through a couple of these. Hopefully this will be easy. Take a look at number 1. What is the biggest power on top? X what? Biggest power on top. X squared. What's the biggest power on bottom? X3. Who's bigger? Bigger on top, bigger on bottom, or both equal?
Bobo.
That makes it a bobo. That means that y equals 0 is your horizontal asymptote. Because remember what that stands for. Bigger on bottom, 0. Okay, number 2. Biggest power on top is a 15x versus a 5x. Are the x's, meaning the power on x, bigger on top, bigger on bottom, or are they the same power? Okay, that counts as the same. Then I divide the numbers in the front. So 15 divided by 5?
3.
Would be 3. Okay, and then if you want to label that, that counts as a bed C. Okay, remember bed C is both equal, divide the coefficients. Okay, last one, bigger on top, bigger on bottom, or both equal? So that makes it a bottom. And remember the N stands for none or no horizontal asymptotes. Okay, which means remember your ends either they go up, maybe they go down, but they don't curve off to anything specific. All right, go ahead and turn the page. Couple more examples like that. For your delta math, they're not always going to come in order. So remember, it's the biggest power on top versus the biggest power on bottom. Take a look at number 4. The biggest power on top is how big? X what? 3. Notice that's not what came first, but it's the biggest. Okay, on bottom, what's the biggest power? Then does that make it a bobo, a bottom, or a bed C? Bed C, and bed C means I divide the coefficients on those x3s. What 2 numbers am I dividing? What kind of 4? -4 is what I'm looking for. So if it counts as a -4, you're going to take that with it. So -4 divided by 2 is what? -2. Great. Okay, one more like that. Biggest power on top is an x squared. On bottom, it's also an x squared. That makes it a tie. Is that a bobo, a bottom, or bed C? Okay, bed C means I divide the coefficients. 10 will not divide evenly by 15, but in your calculator, you can reduce it. Hit alpha x, just like we did last time. 10 over 15. Those can both divide by 5, so it will simplify to 2/3. Okay, so it'd be y equals 2/3. Okay, but remember, it's alpha x for that shortcut on the calculator, and it'll reduce it for you. Okay? All right, next one, number 6. Bobo, bottom, or bed C?
Bobo.
That is a bobo, because it's an x versus an x squared. Bigger on bottom means y equals 0 is your asymptote. Okay, now the next 3 examples, do you see that you have parentheses? Okay, that means that your example is in factored form. So all that you have to do is think about what it would times back together into before you compare. So here's what I mean by that. On top, I have a 4x squared times a 2x. What is 4x squared times 2x the same as? So 4 times 2 is 8x to the 3. Now, I'm not going to times the whole thing together. I really only care about what the x is times 2. Because remember, I want the biggest on top versus the biggest on bottom. Bottom, I have a 2x times a 3x. What's that? 2x times 3x. Uh-huh. And then I Bobo bot and Betsy it. So which one would it be here? Bigger on top, bigger on bottom, or both equal? Uh-huh. So it's a bottom. And remember, the n stands for none. Okay, that you don't have a horizontal asymptote if the top is bigger. Okay, 2 more left like that. Number 8, what is my top x going to be if it were timesed out correctly? 2 times 3x is a 6x. On bottom, what would it be? 15x. And then remember, x versus x, that's a Betsy because the x's are the same. Then what do I do with the numbers in front? Divide. And remember, you can do that on the calculator. 6 over 15 goes to 2/5. When you type these in for your homework, make sure you put the y equals or it'll count it wrong. Okay. All right, last one, number 9. How many x's are going to times together on top? Have an x times an x times a 2x. What is the power going to be on x? How many of them are up there?
3.
Cubed or 3. Good. So 2x 3 versus on bottom, I have a 2x times a 3x. What would that be? Squared. And then I would compare and see which power is bigger. Okay, so my x3 is going to beat out my x2. Is it a Bobo, button, or Betsy?
Oh, Betsy.
yeah.
Betsy.
Not Betsy.
Bottom.
Button. Because it's bigger on top. What's the N stand for? No. Very good. All right, you get the idea? Okay, so now what we're going to do is we're going to take what you learned last class plus Bobo, Bot, and Betsy, and we're going to put it all together. Okay? So take a look at number 10. The first thing that you're going to find is the horizontal asymptote, which is what I just taught you. So look at number 10. Is it a Bobo, a Bottom, or a Betsy?
Betsy.
It is a Betsy. So I'm going to write here Betsy. Remember, that means I'm going to divide the coefficients. That counts as a 4 divided by 1, which means y equals 4 is my horizontal asymptote. Now, today we're also going to be graphing these. So what I want you to do is at y equals 4, draw in a horizontal asymptote. Okay, just like that. The ends of your graph are going to curve off or flatten out to 4. Everything else, though, you should already know how to find from last class. So let's review. We need to factor the top and the bottom. So if I have a 4x squared minus 4x, how can I factor the top of that? Your choices are GCF, perfect squares, or AC chart. GCF, what can I divide them both by? 4x. So the 4x is going to come out. What's going to be left over from 4x squared if I take out a 4x? Just an x. Now, from the second 4x, if I take the whole thing out, I have to leave something. What can I leave? A minus 1. Very good. The top is done. Now let's look at the bottom. I have a 1x squared plus x minus 2. What type of factoring can I do on the bottom? AC chart is correct. So ABC. Set up my little chart here. Air conditioner on top, basement on bottom. 1 times -2 is -2. My basement number is a +1. Okay, remember, if there's nothing in that spot on the x, it counts as a 1x. The only way to times to 2 is 1 times 2. Where will I put my negative to keep my b a +1? On which number? The 1, very good. So it's going to be an x + 2 and an x - 1. Last class, we learned that wholes are the ones that cancel out. Is anything going to cancel out? Very good. So if the x - 1s cross out, then there's going to be a hole in the graph at +1 or 1 comma something. Okay, and then I'm going to put here hole because the ones that cross out are holes. Vertical asymptotes are x's left over on the bottom. Do I have an x left over on the bottom? Okay, I have an x + 2. Then where is the vertical asymptote going to be at? Do you remember from last class? +2 will turn to a -2. Very good. Okay, then my x-intercept is an x left on top. I see that I have one. And it's an x on the outside. What do x's on the outside give you for an answer? 0. So it'll be 0 comma something. And then remember that your y-intercept, the x is always 0, so it'll be 0 comma something again. Now, I want to graph this. However, I cannot graph these points until I know the y's. But the vertical asymptote, I can graph that right now. So remember, a vertical asymptote, we learned this last class, is an x that your graph can't touch. What x can my graph not touch? -2. So go to -2, draw in a vertical line. Okay, your graph cannot touch either one of those lines that you drew. This is a horizontal asymptote that I can't cross. This is a vertical asymptote. To find the y values, remember, we're going to type the parts of the equation that did not cross out into the calculator. So go into y equals. Pull up your pretty fraction, alpha x. And then we're only putting the parts that did not cross out. So for the top, I have a 4x left over. On bottom, I have an x + 2. Then hit second graph, and you're going to find those y values. So second graph. The first y value that I'm looking for is going to be 1's partner. What is 1's partner? 4/3, write it down. Okay, then I want 0's partner. 0 goes with 0. And that's going to go for both of those bottom two. All right, let's finish our drawing. Now, for 1 comma 4/3, okay, in your calculator, hit second quit to get out of this. What is 4 divided by 3 about the same as? So 4 divided by 3 is about the same as 1.3, yeah? So on your graph, I want you to draw a hole where that point should be. So I'm going to go to 1 comma 1.3. That would be here, and I'm going to draw an open circle. So just like that. Your x is a 1. Your y is 4/3, which is a little bit bigger than 1. It's 1.3. So you're just doing your best. Draw a circle there. My x and y intercepts are both 0, 0. So you're going to draw a dot at 0, 0. Okay, then remember what I told you about the asymptotes. Your graph should get really close to those corners. So if you want to look at the picture, you can. Okay, but I can see that I have one piece of my graph like this. And then I have another piece of my graph like this. Okay? And make sure that when you graph it, it should cross through those points that you marked out. So it should hit the whole and it should hit the X and Y intercepts. Okay? All right, so I know that's a lot of steps. Let's try the next one. So go to number 11. First question, is it a bobo, a button, or a bed seat for number 11? Bobo means bigger on bottom. Is it a bigger X on bottom?
Oh,
This is a bed seat. Okay, remember, you're comparing the power. So if it's an X squared and an X squared, that counts as both equal. So I'm going to do 5 divided by 1. What's 5 divided by 1? So Y equals 5 is your horizontal asymptote. Draw that on your graph. So find 5. Flat line through it, my graph cannot cross it. No touching 5. Every other feature you're going to have to factor to be able to find where they are. So look at the top. What can those both divide by on top? GCF divide by 5. Very good. So the 5 is going to come out. That's going to leave me with an X squared minus how many from the 20? 20 divided by 5 is 4. Now, that's not done yet. I have to break it down one more time. Remember, anytime it's an X squared minus, you can perfect squares it. So what's the square root of X squared? So this is going to be 5X and X. What's the square root of 4? Plus or minus 2. Remember, you got to put one of each. On the bottom, I have an X squared minus 2X. What can I take out of both? An X. Let's pull the X out. That's going to leave me with an X minus 2. Everybody good with that? All right. The ones that cross out create holes. Are there any that are going to cross out?
Yes.
Okay, the minus 2's cross out, then the hole will be at 2. Remember, it's always the reverse. So at X equals 2, I'm going to have a hole, but 2 comma what? I'll use my calculator to find that number. Vertical asymptotes are X's left on bottom. Do I have an X left on bottom? And it's on the outside. What do I do for an X on the outside? X equals 0. And I know that I can't touch 0. So I'm going to draw that in right now. No touching 0. Okay, so I can't touch 0 on the x-axis. I can't touch 5 on the y. Okay, my x-intercepts come from x's left on top. Do I have any?
Yes.
I have an x plus 2. Then what's my answer going to be? X equals minus 2. Or minus 2 comma something. Okay, the last point your homework is going to ask you to find is the y-intercept. Remember, your x is always a 0 and it's 0 comma something. In order for you to plot these points, you need to know the y values that go with them. This is where your calculator comes in. So go to your calculator. You're only going to type the pieces that did not cross out. So in y equals, we're going to alpha x, 5x plus 2 on top, and a regular x on bottom. Everything else crossed out. Okay, once you have that typed in, go into second graph, and you're going to find your y values. The first one I want is going to be 2's partner. What is 2's partner? 10. Okay, then go ahead on your graph and map that hole out. So 210 would be here, but I'm going to draw an open hole at that spot, just like that. Next number I'm looking for is -2's partner. What is -2's partner? So go to -2, 0, draw an x-intercept, which is just a regular point where it's going to pass through the x-axis. Okay, next look up 0's partner. What is 0's partner? What does it say? It should say error, because what can I not touch? 0. So it makes sense that I'm not going to have a y-intercept, because at 0, I'm not allowed to touch that anyways, yeah? Okay, then hit graph and just connect your pieces. So when you hit graph, you're going to have a piece up here and a piece over here. Okay, but just do your best. You should hit the dots that you drew. So you have one chunk down here, and then you have one chunk going through the hole up there. Okay? And then remember, those orange lines on the screen, those are your guidelines that your graph should get really close to, but it shouldn't touch them. Okay? All right, maybe we can just do maybe like 1 or 2 more and then give you some time to work on your homework. Let's look at the next one. Is it a Bobo, a Botan, or a Betsy? So I have an x squared and an x squared. That's a Betsy. Then I'm going to divide the numbers in the front. That's a 1x squared and a 1x squared. What's 1 divided by 1? Then my graph cannot cross 1. So go ahead and draw that in. Your flat line at 1 should be just like that. Every other part you have to factor to be able to find. So for the top, what method could I use? Your choices are GCF, perfect squares, or AC chart. Very good. A, B, C. I'm going to do it up here to the side. So I need numbers that multiply to 1 times 4 and that add to 5. What numbers can times to 4 and add to 5? 1 and 4. Now notice my A is a 1. That's good news, because that means those are my parentheses. So it'll be an x plus 1 and an x plus 4. If my A was something else, I would still have to divide and slide, but luckily it's not. On the bottom, what method can I use? Square roots, very good. The square root of x squared will go to x times x. And then the square root of 1 will go to a plus 1 and a minus 1. The factors that cross out create what? Starts with the H. Holes. And if I cross out plus 1s, then the hole is going to be at x equals -1 or -1 comma something. Vertical asymptotes are x's left on bottom. Do I have any? And it's an x minus 1, so where's the vertical asymptote going to be at? +1. Then go on your graph and draw that in. My graph cannot touch an x of 1. That would be here. So no touching +1 for x or y. Any x's left on top for an x-intercept? Yeah, we have a +4, which means it's going to cross the x-axis at -4 or -4 comma something. Then remember your y-intercept, the x is always a 0, and you're just going to look up its partner in the chart. Okay, now you go to your calculator, you're going to find those y values. Remember though, when you type in, you're only going to put the parts of the fraction that did not cross out. So that's an x plus 4 on top and an x minus 1 on bottom. Now, when I go into my chart, I noticed that at 1, there's an error. Does that make sense why I'm getting an error at 1? Because what do I have there? Vertical asymptotes you can't touch. So it makes sense that I'm seeing an error there. Okay, for -1, my y value is a -3/2. For -4, my y value is a 0. And at 0, my y value is a negative. So let's plot those on our graph. -4, 0 is here. You can check it off if you want that we did it. 0, -4 would be here. Okay, my x and my y intercepts are plotted. Okay, and then for this third point, if it's a -3/2 for the y value, what decimal is that the same as? 1.5. Good. Now, if you don't know how to do that, that's fine. Just hit second quit, divide -3 by 2. So now I know that that's a -1.5. So I'm going to write that right below here. Sometimes as a decimal, it's a little bit easier to know where to graph it. And then remember, that's a hole. So you're going to graph an open circle at that spot. So go to the left one, down 1.5, leave it open. Okay, just like that. And then you should be able to kind of predict what the graph is going to look like. These are going to connect. And then your other half of your graph is in the other corner. Okay, but if you want to hit graph on your calculator, you'll be able to see it there as well. Okay, for today, you're not having to actually draw the graphs, I don't think, in the homework. You're just filling this part out. Okay, by next class in the homework, you'll be actually graphing it. I think. That could be wrong, but we'll see. Okay, go ahead and turn. We're going to just do one more. Which one are we going to do? Let's do, I don't want to do either of these. I'm going to pick one off your homework, okay? Pull out your Delta Math or your computers, get into Delta Math. We'll do one more example in your notes, but we'll pick one that's on the homework. Okay? All right, your homework should be unhidden now that you can see it.
Nah, Michael Jackson. Chicken costumes like 2 messes with the taser in her mom.
All right, I'm just gonna do maybe the first question, okay? So go ahead and scribble out. The reason I don't want to do the one in your notes is because it has grouping in it, and that just takes forever. And you don't have any grouping on this homework. So go ahead and cross out the equation for 13. Let's write in the one off your homework instead. So it's y equals 2x minus 7 over -3x minus 9. Okay? All right, so first question, is it a Bobo, a Botan, or a Betsy?
Betsy.
It is a Betsy, very good. Now for the Betsy, it's both equal, they're both regular x's, so I divide the numbers in the front. So I'm dividing 2 by -3. Now, for your homework, remember what I told you, you don't actually have to graph it. So type into the box for horizontal asymptote, y equals -2/3. Okay, so type it into the box over here. So y equals -2/3. And actually, I'm realizing the y equals is already there. So don't type another one. Okay? So far, so good? Okay, now on your notes, I want you to go ahead and graph. -2/3 is 0.6. So I want you to draw in a flat line right here. Okay, your graph cannot touch -0.6. About, we're just estimating. Okay, every other feature I have to factor to find. Now, take a look at the top. 2x minus 7. Can I factor that? Can those both divide by any of the same things? No. So the top really is done. Okay, I'm just going to keep the 2x minus 7 as is. Okay, there's not anything I can do to that would factor it. What could I do on the bottom? Okay, GCF out what? What kind of 3? Take out a negative. Okay, remember, if the front one's negative, you want to pull that out. So my -3 is going to come out. My x is alone now. What's going to happen to my -9 when I divide by -3? -9 divided by -3. Plus 3. Very good. Okay, now to find the holes, I'm looking for crap that should cross out. Is anything going to cross out? No, because the top and the bottom don't have any repeats. So under holes, will you click no hole? Okay, if nothing crosses out, then you're not going to have any holes on this graph. Okay, so for holes here on the notes, I'm going to put none because nothing crosses out. Nothing cancels. Okay, vertical asymptotes come from x's left over on bottom. Do I have any x's on bottom? Yes or no?
Yes.
Yes, I have an x plus 3. Then where is it going to be at? What number? X equals -3. Right. So go into your vertical asymptote and type x equals -3. Because I did have an x on bottom. And it was a +3, so I type in a -3. Okay, the last two features are the x and y intercepts. Did I have an x left over on top? Yes, my x on top has a -7. What do I change it to? +7, and then I slide down the 2. So that would be 7/2, comma something. Now, for your homework, you can leave it as a 7/2. So go ahead and in the x-intercept box, type a 7/2. The y-intercept is 0's partner, and I know I'm going to have to look that up in the calculator anyways. Now, when you type this into the calculator, are there any parts that you're not going to write? Did anything cross out that I can eliminate? No. So go into your y equals. We're doing a 2x minus 7 on top. We're doing a -3x plus 3 on bottom. And then I see that 0's partner is a 7/9. And then you should have noticed the pattern that for your x-intercepts, the y always comes out to a 0. So I won't see 7/2 in my table, but I know the partner's a 0. So for your homework now, you should be able to just type those in. Now, just for your notes, I do want to finish the graph, so let's do it. Okay, at -3, drawing your vertical line, your graph can't touch it. No touching -3. 7/2 is about the same as 3.5. So go to 3.5, 0, and we're going to draw an x-intercept. And then 7/9 is like 0.8. So we're going to cross a little bit below 1. And then if you hit graph, you should be able to connect the dots. You're pretty much always in the corners. So you're going to have one piece that's down here. And then one piece that hits those guys. Okay. But notice that this graph didn't have a hole because nothing crossed out. Okay? But for your homework, you don't have to do any graphs yet. You're just typing in the pieces as you go. Okay? All right, give the next one a shot. You can do it.